All right, guys. This is the end of week 4 here, and this is going to be the last thing we're going to do with box and whisker plots. This is lesson 3. Now, what we did in lesson 2 was we just did our basic box and whisker plot, hopefully something that you've done before. I spent some time there so we can go through and do what we need to get to here for our Math 3 Foundations of Math 3 class. What we're going to look at is a modified box and whisker plot. What that means is instead of just doing our casual box and whisker plot like we did before, we need to check for outliers. That's what's going to make this modified. Now, if you don't remember what outliers are those numbers that are super far away. Say I was looking at an average test score, and we had scores of like 70, 75, 82, 76, and then someone scored a 10. Right? That 10 would be an outlier. What we're going to do today is look at how can we find that outlier and how are we going to represent that on our box and whisker plots. Now, if you look at this example, this is the same exact example that we ended with on lesson 2. What we're going to see is, are there any outliers? How is that going to affect our box and whisker plot? So we're going to go through and we're going to do these first steps just like we did before. We won't graph it, but we're going to take the same steps there. Our first step is organize the data. So let's rewrite it. We have a 1, a 3. We have 2 13s. We have a 15, 17, 18. And then 20 and 37. Again, we're going to go through and find these 5 numbers. If you don't remember how to do it, I'm going to do it again with you guys here, just to make sure that we're all on the same page. The minimum and maximum is pretty easy. The minimum is your smallest number. The maximum is your largest number, right? That should be fast. Now we need to find the median. If you don't remember how to find the median, what we do is we go in one step at a time, or one number at a time, until we find that number that's in the middle. That's why we call it the median. In this case, our median is 15. Q1 and Q3, again, we went through this process on our last lesson there. To find Q3, I'm trying to find a new color to use here, but I figured, I guess I must have ran out. To find Q3, again, what we're going to do is we're going to split our data in half using the median. That's what splits it in half. And we're going to go through and we're going to find what number is in between the first half and what number is in between the second half. Sorry about that. So we go in. We end up with 3 and 13. We look at what number is in between 3 and 13. That's our Q1. So 3 plus 13 divided by 2. Let me zoom in. 16 divided by 2 is 8. I know we've done this before. We have Q1 is 8. I just want to show you guys this is the same thing that we did. It's just we're adding on some steps, right? We find the median for that second piece. We end up between 18 and 20. Between 18 and 20 is our Q3, which is 19. If that's all we were doing and we just needed a box and whisker plot, we can go ahead over there and find it. But we have to do something different here. So what we want to do now is we're going to look and see, are there any outliers in this set of data? The first thing that we need to find is the IQR. Now what the IQR stands for is the interquartile range. Now, range, if you remember, is when we did the biggest minus the smallest, but specifically we're looking at quartiles. The quartiles are what Q1 and Q3 stand for, right? Q1 is quartile 1. Q3 is quartile 3 because it's splitting our data up into quarters, right? So to find the interquartile range, we're just going to go Q3 minus Q1. And that's going to tell us our range, but for the quartiles, right? So Q3 is 19 minus Q1 is 8. 19 minus 8 is 11, right? So that's our interquartile range. Okay, now that that is done, we need to find the lower boundary and the upper boundary, because what's going to tell us where these outliers are these lower boundaries and upper boundaries. To find the lower boundary and the upper boundary, we're going to use the interquartile range and we're going to use the quartiles. To find the lower boundary, what we're going to do is we're going to use Q1 and we're going to subtract 1.5 times whatever the IQR is. Right now, that's the formula we've come up with because 1.5 is about 150% away from Q1, which means if it's farther away from that, then it is an outlier. So Q1 is 8 minus 1.5 times, we just found our IQR is 11, and let's just punch that into a calculator. Now remember order of operations, right? For order of operations, we do 1.5 times 11 first. So 1.5 times 11 is 16.5. So we're going 8 minus 16.5. 8 minus 16.5 is negative 8.5. So our lower boundary, I'm going to say, is negative 8.5. What that means is any number below our lower boundary is an outlier. So we look back at our data, our lower boundary is negative 8.5. Are any of those numbers below negative 8.5? The answer is no, because none of those numbers are negative. So we don't have any outliers there. For our upper boundary, though, the way we check that is instead of subtracting, we're going to add, and we're going to use Q3. So to find our upper boundary, we're going Q3, but we're adding 1.5 times the IQR. So a very similar idea. Q3 is 19 plus 1.5 times 11, and we're going to plug that in. So let's go 19 plus, in this case it's 16.5. We've already found that. Let's go 19 plus 16.5. That's 35.5. So our upper boundary is 35.5. For our upper boundary, any number above the upper boundary is an outlier. So we look at our set of data. Are there any numbers that are bigger than or above our upper boundary of 35.5? And the answer is yeah, that 37 is bigger than 35.5. So that means an outlier for our data is 37. And it makes sense, 37 is pretty far away. I'm going to say this is an outlier. And we'll say that 37 because is greater than 35.5. We don't have to put an explanation, but that's why. That's our outlier. Now, how does that affect our graph? What we're going to do is we're going to kind of go through the same process of graphing, right? We have our number line. We want to graph it. Let's use the same scale as we did last time. Start at 0, go by tens. 30, 40. When you're graphing this, though, it's a little different. What we do on the graph is we don't include the outliers, right? So we start off with, let's start with the box, right? Q1, the median, and Q3. So Q1 is 8. That's somewhere right here. The median is 15. And then Q3 is 19, just a little bit in from that 20 there. So the box stays the same, nothing changes there. It's where the whiskers go. The whiskers, I'm going to put it down here, whiskers go to the lowest and highest number that is not an outlier. So what that means is let's go for that left-hand whisker. we're going to go to the lowest number that's not an outlier. The lowest number in our set of data that's not an outlier is 1. So that's fine. That is going to stay the same. For our whisker going to the right, though, we look at what's the highest number that's not an outlier. In this case, that's 20. So we're going to go to 20 for that whisker. Notice how that's going to go right there. We have a really small whisker. It's right on the end of our quartile 3. That's how our box and whisker plot has been modified. We took the outlier out. Now what I want to do as well is we're going to throw the outlier on there. That's over here at 37. But instead of putting a line and connecting it, I'm just going to put an X there and say that's an outlier. But that is the process of doing a modified box and whisker plot. I know there's a few steps there, but you know how to do the box and whisker plot. You just need to find if there are any outliers. That's what we added in there. Again, keep in mind, these two formulas here will always stay the same to find the outliers and to find the IQR. If you have any questions, feel free to email me and let me know. Other than that, make sure you have a good day and stay safe.